Hello everyone, my name is Quentin and today we're gonna see how to make a procedural Laurel wreath in Houdini, where we can control the length of it, how much leaf there is, the angle of the leaf, how much they are lifted or not, and much more. So let's get started. I'm gonna start with an empty geometry node, and I'm gonna jump in it. The base of our laurel is gonna be a line, basic line in the Y direction that I'm gonna resample. And in the resample node, I'm gonna activate curveview attribute. Now I have a bunch of points every 0.1 distance. And the magic is gonna be made inside a point triangle. I'm gonna call setup. So, first thing I'm gonna do is create two vectors that are gonna be useful for the setup and when we're gonna paste the leaf on the point. First one is of course n. At n is equal to, I'm gonna orient n in the y direction. And I'm gonna create a second vector that's gonna be called up, and this one is gonna be in the z direction. Apply. I can see they're going up. So first thing I want to do is orient my leaf left and right. It's going to be the end that I'm going to orient. The leaf will come later. To do this, I'm going to have to decide of how much angle I want to rotate n. So for that, I'm going to create a parameter. I'm going to create a float called angle that's going to be controlled by a parameter named angle. Once I have this, I'm gonna want to I'm gonna have to create a quaternion to deal with the rotation. So for this, I'm gonna need a vector 4 that I'm gonna call rot for rotation, and it's gonna be equal to the function quaternion that can take two input, a float angle and a vector axis. So first my angle, but my angle as I'm gonna write it is gonna be in degree. The quaternion needs a radian, so let's put in the radian function of our angle parameter. And the second one, the vector around which we're gonna turn, is gonna be up, so v at up. And to rotate it, it's gonna be at n is equal to the function qrotate for quaternion rotate. That takes two input. First one, the quaternion rot, and second one, the vector we want to rotate at n. Apply, accept, closing this, and going back here so that I can create the parameter. Let's see if I put like 45 degree in my angle, it's working. I can rotate my angle. Next thing I want to do is alternate between left and right, so between positive and negative value for my angle. For that, I'm going to create a condition just after my angle, and this condition is going to be if the Ptinon modulo 2 is strictly equal to 0. So if it's odd or even, not sure which one, don't care. Then angle is going to be multiply equal by -1. And ta-da, we have a nice switch between left and right for our vector. Last thing I want to do for my angle, so for this orientation, is I'd like to control how much they are rotated based on the curve view attribute. So I'm gonna modify the angle, the float angle, by multiplying equal to a ramp based on the curve view parameter. So to call forth a ramp, it's channel ramp. You want to name it angle by curve view, for example, and you want to give it the attribute it's working on, and that's at curve view. I create it, and now you can see at the base where it's equal to 0 we have no rotation, and at the top where it's equal to 1 we have a full rotation. For me, I'm gonna want to have the opposite, so let's reverse our ramp and maybe a little bit less at the tip to keep a little bit of an angle. Okay, first thing done, we can orient our normal towards the side. Now I want to be able to orient it up so that if they're too close together, I can have one on top of another without too much intersection. So that's going to be our second part, sorry, that I'm going to call lift and it's going to be basically the same thing as we did before. So let me copy most of our code, if not all of it. And let's change it a little bit. So instead of having angle here, I'm going to call it L angle for lift angle. Then L angle is also going to be multiplied by a ramp based on curve view. So it's going to be lift angle by curve view. Same for here, not L angle, but lift angle. Vector for rot, so I don't have to declare it since it already exists, and I can write another value on it. It's going to be based on lift angle, and this time we're not going to use up. We're going to want a vector that's in the y direction, and instead of creating it, since I'm just using here, I can declare it between two brackets, and it's going to be 0, 1, 0. What's going on? Apply, you have a problem. 0, 1, 0. Okay, he's happy. Let's create the parameters, see if we've done the thing right. And let's put like 45 in the lift. Let's look on the side. Seems to be working. It's lifting mostly at the end, since that's where the curve view is equal to 1. I'm gonna reverse this domain and change a little bit my ramp. Okay, that's for the first two things we want to do with the normal. Actually, that's the only thing we want to do with the normal. Now we're going to want to be able to modulate the Pscale of our leaf based on their position in along the curve. So third part, where we set the Pscale. And that's going to be pretty quick. I'm going to write it in just one line. at Pscale is equal to a channel ramp named Pscale by curveView using the curveView attribute. And I'm not gonna just leave it there because I don't want to have necessarily a Pscale going from 0 to 1. I'd like to have a little bit more control, so I'm gonna use the fit 0,1 function to remap my ramp between two parameter CHF. I'm gonna call the first one Pscale underscore min, and the second one that's gonna be called Pscale underscore max. Let's close the part. Let's close everything. Let's see, can I increase it so you can see the code a little bit better? So that's basically all we need. Create the parameter, and now here I have Pscale min and Pscale max. To see a bit better if it's working, let's create our leaf. Not gonna go in great detail here. Let's do a simple grid. That's gonna be 1 by 1 with only 2 row and 2 column, and I'm gonna rotate it 45 degrees in the Y direction. Now that I have it here, what I want to do is reduce the scale in the X direction using a transform. Let's half it. I'd like to round a bit those two edges using a bevel mode. Group type point, on which point it's going to be on those two. Let's increase the distance, add some more division, and voila, or basically last thing I want to do is move it so that the whole leaf is only in the positive Z axis using a match size node and justifying it in Z so that there is nothing in Z min. That's our leaf. No null to be tidy. And let's copy to point our leaf on our line to see if we've been nice and efficient. Well, that's definitely working. I can see that I'd like to reverse my Pscale ramp. So Pscale by curveView, let's reverse it, and I'm gonna go between, like, say, yeah, 0.3 by 0.1. Oh, that's kind of fun. I don't know why it's giving me a division on one of the leaf where I don't have any there. For copy to point, that's unusual. It's gone. Well, that's cool. So it's working properly. We can see in the setup, if I change the angle, we can flatten the leaf, more or less. Change the angle if you want it more or less spread out. That's cool. I'll say we're done with the attribute triangle. We could change a few of the parameter. For example, the angle between 0 and 1, it's not very useful. So let's go into the edit parameter interface. The angle is going to be between 0 and 90. Same for the lift angle, 0 and 90. And if I like, I can make it a little bit nicer by adding a spacer between the angle and the lift angle and a separator between the lift angle and the Pscale. Apply, accept. And voila. Let's add some angle. Okay, I'm gonna increase my line length to maybe 2. It's a bit longer. And now to shape the wreath, I'm not sure how to pronounce it, don't need to create it. I'm gonna use a transform node. After my setup, let's rotate it by -90 in the y direction. So it's lying on its side. Let's create the branch that's gonna connect all our leaf together. That's gonna be a sweep node connected to the transform. On this sweep node, let's change the surface shape to ribbon. Let's reduce the column to 1. And I think that's all you need. We're getting the Pscale nicely. And let's merge the result of our copy to point to the sweep. And ta-da! Now let's bend it so that we can get the correct shape using a bend node. I'm going to add some value in the bend to see if it's working well. And I'm gonna, let's see, by visualizing it. Okay, so it's bending this way, that's not what I want. Let's see, capture direction is gonna be Z, is gonna be X, I guess, yes. And the length is gonna be 2, since my line is 2 in length. Let's increase the bend to something a bit bigger so I can see it. Okay. And all we need now is to add a mirror after that. So we can have both of them. Little null to say we're down. And an output node to protect us from ourselves, so that it's always the final result that come out. Perfect, we're done. Now it's all about tidying it up and making it easier to use. I'm gonna create a null that's gonna be my control. Look how important it is, it's red. And I'm gonna edit the parameter interface. Since I'm lazy, I'd like to be able to just get one of the parameters that's interesting me and drag and drop it, but Houdini won't do it. For that, I have to click on this little wheel and uncheck forbid linking parameter from outside the subnet. And now I can do whatever I want. I can put the length here, call it overall length, apply. I can grab in my resample the resample length, apply. In my setup, I'm gonna grab everything I've created, the angle by curve view, lift angle by curve view, my Pscale mean, my Pscale max, my Pscale by curve view. Let's put some separator in there to make it a bit nicer. Apply. Okay. What else do I want to get? I want to get my bend. So bend. I'm also going to want to get the twist. Could be useful. Apply. And I think that's all we need. Accept. Now we can see in the control, everything is there. Last thing I'm gonna do before calling it down is I'd like my bend capture length to be equal to my overall length. So let's go into our line, copy this parameter, and paste it in the capture length. Paste relative references. And now, from here we have all the parameter we need. Overall length, more or less long, more or less leaves. Let's change the angle if we want to. Let's change the lift if we want to. We can change the Pscale. We can change the bend. I'm gonna change this parameter to go from -90 to 90. That's not enough for me. So let's say the bend is gonna be between 0 and 360. Apply, accept, and the twist is, oh yeah, that's good. Apply, accept. So I can bend it and add a little twist if I'd like to. And that's how you make a procedural, let's call it scissor headset that I can pronounce. Okay, I hope you learned something. I'll add the code in the video description. And I'll be wishing you a happy holiday. That's all for today. Thank you all for following this video, and bye bye.